Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics, Chapter 7 Linear Programming, Long Question Example 4. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. A manufacturer of wooden furniture produces two types of furniture, chairs and tables. Two machines are used in the production, machine A and machine B. Each chair requires 1 hour on machine A and 1 hour on machine B, whereas each table requires 1 hour on machine A and 2 hours on machine B. Machine A and machine B can operate for a maximum of 10 hours and 12 hours respectively per day. The number of chairs produced cannot be less than 2 times the number of tables produced. The number of chairs and tables produced in a day are X and Y respectively. So for the question part A, write down 3 inequalities other than X more than equals to 0 and Y more than equals to 0 which satisfy the above constraints. For the question part B, hence use a scale of 2 cm to 2 units on the x-axis and 2 cm to 1 unit on the y-axis. Construct and shade the feasible region R which satisfy all the above constraints. Okay, so from here let me read the question part C. Using your graph in question part B, find the maximum number of chairs and the maximum number of table produced if the number of chairs produced exceeds the number of table produced in a day by 4. So this is the question C part 1. So let me read the question C part 2. The maximum profit that can be obtained by the manufacturer in a day if the profits from the sales of a chair and a table are 6 ringgit and 8 ringgit respectively. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Let us start our discussion for the question part A, where we need to write down the 3 inequalities which satisfy the above constraints. Okay, in this case, the constraint is in the form of statements. So we need to identify in which statement we can form the constraints. Okay, but before that, it is important for us to identify which is the X and Y. Okay, so if you read at the last sentence here, it mentioned that the number of chairs and tables produced in a day are X and Y respectively. So from here you should know that X is actually representing chairs and Y is actually representing the tables. Okay, so let me write down in the working here. So from here, X is actually equals to chairs and Y is actually equals to tables. Okay, so this information is crucial, guys. Okay, once you identify this, then only we can proceed for the other informations. Okay, so this long statement, what we're going to do is we're going to break into simplified version. Okay, so let me read this statement here. Okay, it mentioned that 2 machines are used in the production, machine A and machine B. Okay, so from here within the chair you are using machine A and machine B. So what I'm going to do is, so I'm going to write here chairs and tables. Okay, 2 separate informations. Okay, let's begin with chairs. Okay, and followed by tables. Okay, let me underline this 2. Okay, and I make a line for the comparison. Okay, so from here let us start with the chairs. Okay, so from here it mentioned that each chair requires 1 hour on machine A and 1 hour on machine B. So just write here A is equals to 1 hour. Okay, and then machine B is equals to 1 hour. Okay, so it is understood, guys. Okay, I write here A and B, but then in the statement here it mentioned machine A and machine B, so it is understood. Okay, this A is actually representing machine A and this B is actually representing machine B. Okay, so let's continue with the tables here. Okay, whereas each table requires 1 hour on machine A, so from here A is equals to 1 hour, and for machine B is actually 2 hours. Okay, machine B is 2 hours. Okay, so this is the important information. As you can see here, now it's better for us to read, okay, as compared to the long statements over here. So this is the important skill that you need to know, guys. Okay, by breaking this long statement into the simplified information. Okay, so from here, once you're done with this, okay, let us proceed to the statements that will lead us to the constraints. Okay, so from here it mentioned here machine A and machine B can operate for a maximum of 10 hours and 12 hours respectively per day. So within this sentence, you can actually form two constraints. Let us begin with the machine A first. Okay, so this is our constraint 1. So what we're going to do is we're going to start to calculate for the machine A first. Okay, so from here machine A, okay, for chairs is actually 1 hour and for tables is actually 1 hour as well. Okay, so from here what you're going to do is X hours of chairs and then you plus with Y hours of tables. Okay, it should be less than equals to 10 hours. So this will be your first constraint. Okay, and I write in the bracket here machine A. So this is your constraint for machine A. Okay, so continue to the second constraint. Okay, so this is for the machine B. Okay, similar step as the first constraint. So from here X hours of chairs, okay, and then you plus with 2 Y of tables. So it should be within 12 hours. Okay, so this is for the machine B. Okay, guys, so I hope you guys are clear about this. Okay, and it mentioned here the number of chair produced cannot be less than 2 times the number of tables produced. Okay, so from here the number of chairs is actually representing X. Okay, by the way, let me write here the constraint 3. Okay, so from here the number of chairs is actually representing X. Okay, it said cannot be less than 2 times. If cannot be less means it should be more. So in this case it should be more than equal to 2 times the number of table produced. Okay, in this case table is actually Y, so it will be 2Y. Okay, so from here, since we are going to plot the graph in our upcoming working, so what you do, you shift this inequality. Okay, so from here 2Y, it will be less than equals to X. So from here to find your Y, it will be less than equals to 1 over 2x. So this is your third constraint. Okay, so let me underline all the respective constraints. Okay, so we are done with the question part A, where we have already write down the inequalities from the constraints. Okay, so from here let us proceed to the question part B. For the question part B, we are required to plot the graph based on these 3 linear inequalities, and we need to shade the feasible region R. Okay, by the way, I've already completed the graph and shade the region R for you. So let me show you the complete linear programming graph now. So please wait for a moment. Okay, so this is the complete linear programming graph. So let me zoom in a bit. Okay, so as you can see here, this is the title of the graph where it mentioned here linear programming of chairs and table. Okay, so as you can see here, we have fulfilled the scale 2 cm to 2 units for the x-axis and 2 cm to 1 unit for the y-axis. Okay, so I hope these are visible to you. Okay, so from here, let us begin with the first constraint where x plus y equals to 10. Okay, but then you cannot write the inequality first. You need to plot the straight line. Okay, for that you need to change this less than equal to equal sign. So from here, x plus y equals to 10. So from here, what you do, you use the 2 points. Okay, the easy 2 point you can form is the intercepts. Okay, you can use the y and x intercept. Okay, 10 and 10. Okay, you choose those 2 points and you plot the graph of x plus y equals to 10. Okay, that will be your first constraint. Okay, as for the second constraint, so this is your second constraint. Okay, not this dotted line, guys. Okay, this complete straight line. So as you can see here, x plus 2y is equals to 12. Okay, you take out the inequality and you put the equal sign over here, since you need to plot the straight line first. Okay, so from here, similar concept, you choose the intercepts. Okay, as it is easy for us. Okay, in this case, your y-intercept is 6 and your x-intercept is 12. So you choose those 2 points and you plot the straight line graph. So this is how your second constraint is formed. Okay, let us proceed to the third constraint. Okay, y is equals to 1 over 2x. Okay, so for this, you can choose any 2 points. Okay, so this is the 2 points that I choose. Okay, you can choose the origin, and then the second point I choose is the coordinate 2, 1. Okay, you choose those 2 points and you plot the graph of y equals to 1 over 2 x. So that is how the third constraint graph is formed. Okay, so this dotted line, as you can see here, you have 2 dotted lines here and then the 2 points over here. So those discussion I will come back to you for the question part C, guys. Okay, but for now, let us focus on the question part B. Okay, so that is all. Okay, let me close this and open the second graph paper. Okay, so now I'm going to show you how I perform the shading of the region. Okay, so let us begin with the x plus y equals to 10. Okay, so from here, since it mentioned for the first constraint where your x plus y less than equals to 10, so from here you need to shade the below region. Okay, so you need to mark all the possible region, guys, like I mentioned. So you need to mark here. Okay, let me make it visible enough. Okay, you need to mark here. Okay, you need to mark here. You need to mark here. Okay, you need to mark here. Okay, how about this region? Okay, this region you cannot mark, guys, because it's already exceed the x plus y equals to 10 line. Okay, so you cannot mark over here. Okay, let me shade it properly over this. Okay, so we have done with the first constraint where x plus y less than equals to 10. So let us move on to the second constraint where x plus 2y less than equals to 12. So this is the straight line x plus 2y less than equals to 12. So we need to form the shading for this. Okay, for this, since it mentioned less than equals to, you need to shade the down region. Okay, so from here you mark here. Okay, and you mark here. Oops. Please wait, guys. Okay, mark here. Okay, you mark here. Okay, and you mark over here as well, because it is below, guys. So that is the reason why you need to mark here. Okay, so from here, let me double check again. Okay, you mark ready. Okay, so over here, okay, all right, so that is all for the second constraint. So let me move on to the third constraint. All right, okay, for the third constraint, it mentioned that y should be less than equals to 1 over 2x, so it should be below this region. Okay, so we'll mark here. So we mark here, you mark here, and you mark here. Okay, so that's all. I think we are done. Okay, so from here, once you mark all the region, you need to check which region has most colors. Okay, in this case, as you can see here, this particular region has the most number of colors, okay, which fulfills all the inequalities. So that is the reason why, that is the reason why I shade this region and form the letter R over here. Okay, so I hope you guys are clear about this. So let me erase this. Okay, so from here, let us proceed our discussion for the question part C. So let me close this and back to our main discussion. Okay, so for the question C part 1, we are required to find the maximum number of chairs and maximum number of tables produced if the number of chairs produced exceeds the number of table produced in a day by 4. Okay, sound confusing? Okay, don't worry. Try to break this information into the equation form, guys. Okay, so don't worry, I'm going to guide you for this. Okay, it mentioned here, if the number of chair produced, okay, you should know that chair is actually x. So from here is x, okay, and then exceeds the number of tables. Okay, so x is equals to, so from here you know that tables is actually representing y. Okay, and then take a look at the keyword here. It's mentioning exceeds, so it should be more. So from here, x should be equals to y plus with, okay, how much it exceeds? Okay, it's exceed by 4. So from here, it will be x equals to y plus 4. Okay, so from here, if x is equals to y plus 4, so from here, y should be equals to x minus 4. Okay, so this is the straight line equation form, guys. So that is the reason why I'm expressing the equation y in terms of x. Okay, so from here you need to choose any 2 points in order for us to plot the graph. Okay, by the way, I've already plot the graph for you, so let me show you the graph now for this y equals to x minus 4. So let me open. Okay, so as you can see here, this long dotted line is the equation of dotted line where y equals to x minus 4. Okay, so you choose any 2 points over here. So the first point I choose is the 4 0. Okay, and the second point I choose is the 8 4. So you choose any 2 points and then you form the straight dotted line for the equation y equals to x minus 4. Okay, up until now, I hope you guys are clear about this. Okay, so for now, we are required to find the maximum numbers of chairs and tables. So from here, within this dotted line, you need to check which is the possible number we can able to come up in order to have a maximum number of chairs and tables. So from here, as you can observe, you can have 6 chairs and 2 tables as the maximum. Okay, if you put your point over here, you will end up by getting decimal. So it is impossible to come up with a decimal numbers of real life objects. So this 6 and 2 is the only possible answer. Okay, I mean the only possible maximum chairs and tables that we can come up with. So I hope my explanation helps you a lot for this. So from here, back to our main discussion. Okay, so from the graph, okay, we found out that your maximum number of chairs or x maximum is equal to 6, and your maximum number of tables or y max is equals to 2. And as you can see, it is fulfilling the condition as well. Okay, it mentioned that your number of chairs must exceed the number of tables by 4. Okay, it is proven, right? So this is your answer. Okay, so let me underline this first. From here, for the question C part 2, we need to come up with the profit equation, okay, where P is equals to 6x, okay, because profit for the chair is 6 ringgit, so 6 times with x number of chairs, okay, and then plus with 8 ringgit times with y number of tables. So this is your profit equation. So let me box this. Okay, so up until now, I hope you guys are clear. So from here, to proceed to the next step, we need to form an imaginary straight line. So to form an imaginary straight line, what we need to do, we need to set a value for the P. So how to set the value? You can use the LCM method, guys. For instance, 6 you can times with 8. So from here, you can let your P is equals to 48. Actually, you can choose any P value, but in this case, I prefer to use the LCM. So it is up to the students, guys. Okay, so from here, 6x plus with 8y, it is equals to 48. Okay, so you need to choose any 2 points. Okay, in this case, we are going to use the intercepts, okay, as it is easier for us. So from here, when x equals to 0, so from here, you will get your y is equals to 6. Okay, so this is your y intercept. So let us move on to the x intercept. So from here, when y equals to 0, so from here you get your x equals to 8. Okay, so you have these 2 points, so you can use this to plot the dotted line, okay, the imaginary line of the profit equation. So let me open the graph paper now. So as you can see here, this dotted line is the equation where 6x plus 8y is equals to 48. Okay, this dotted line. Okay, so let me open this second explanation. So you have to write here 6x plus 8y equals to 48. Please wait, guys, let me write under here. Okay, so this is your dotted line equation. So from here, what we need to do is we need to find the possible maximum value. So to find the possible maximum value, what you do, you use a ruler and then you push it towards the perpendicular direction of this dotted line, okay, in reference to this dotted line. Okay, as you push further, you will find out that this is your maximum point. Okay, not this, guys. Okay, this won't give you a maximum point, but this. Okay, if you put your ruler over here, you can find out that there is still some region left for you to push. So this is the furthest region that you can possibly push. So that is the reason why 8.2 is our maximum point over here. Okay, so I hope I made myself clear about this for the explanation of why we get this maximum point. Okay, so from here, back to our main discussion. So from the graph, okay, so from here we get our maximum point is equals to 8,2. So from here we can use this point to find our maximum profit. So from here, our maximum profit is equals to 6 times with 8, okay, and then plus with 8 times with 2. So use this point and you substitute into the profit equation. So you perform the calculation. So from here you should get your maximum profit is equals to 64 ringgit. Okay, so this will be your answer for the question C part 2. So let me underline the solution. Okay, So that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I'll see you in the next video.